Hey guys, what's up? Good evening, one and all present here. So, I am your host, Shreyansh, for today's event. First of all, thank you to each and every one of you for being here with us today. We are very pleased to be able to welcome those of you that have been here with us for a long time and those who are new to this community. Though this event would have been much more interesting in offline mode, but let's not get stopped because of that. My team has put a lot of efforts into the preparation of this event, so I can assure you that it will be as interesting as you would have attended this event in offline mode with your support, which is, of course, the most important part. I guess many of you present here are from first and second year, so you would have seen many of your colleagues around you have already chosen their path. So the with the help of this event and further events in DSC, you will get a clarity about what to choose as your domain in computer science. By attending this event on machine learning, my colleagues will explain to you the basic concepts, problems they faced while learning this particular technology, and resources to refer to if you feel that ML as a domain is your calling. So today's event is on the topic Basics of ML by our DSC technical team members Khushi and Disshad. But before that, I would like to speak some points about DSC SRM Ramapuram. So yes, this is the DSC SRM Ramapuram dashboard link. I'll make sure that it is posted in chat box. So kindly get yourselves registered in this, and also tell us about your interests. And if you have any questions regarding anything, just let us know in chat box about that. Okay. So yes, so domains we are gonna focus on are AIML, which of course is today's event as well, web development, Android, iOS, cybersecurity, cloud, competitive programming, interview preparation, and DevOps. So, what kind of sessions are these actually? So, these are hands-on workshops, solution challenge, and expert tech talks with Google AI Explore ML, cloud study jams, and some engaging challenges as well. So let me tell you how DSC will help you grow. Rather, I have said it before as well, but it is going to improve your skills, and you will get an opportunity to teach others, grow networks, and meet like-minded people. We all are very like-minded people right over here. So you will also get a chance to get your blogs, projects, and story showcased on our social handles, website if possible, and official DSC handles as well. You will also get recognized for your efforts, of course, and you will also get access to resources provided by Google developers. So one thing which I wanted to talk about is Google Cloud. You can get a chance to become a Google Cloud facilitator for our college, where you can mentor students about cloud concepts and also get swags. The application criteria is simple: just fill the form, and a will to learn and help others is all we need. And all details will be listed in the form, which is visually posted in the chat box. So well, follow us on these links. I'm going to we're going to put in the all the links in the chat box. So kindly follow all these handles. And well, I don't want to take too much of your time. I need to leave some time to introduce themselves to all of you and fill you in on with today's event. So today will be fun and full of learning. All the best, guys, and enjoy the event.
So, hey guys, I'm Disshad. I'm from second year CSEC section, and yeah. So today we will be looking at a brief introduction to machine learning, all the core concepts, and we would be going through a lot of fun stuff. So yeah, are you able to see my screen, guys?
Yes, we can.
Okay, cool. So yeah, so again, good evening, guys. I'm Disshad from CSEC section, and today we are going to look at basics of machine learning. So, what are we going to do today? Our event flow would be like we'll introduce you to what machine learning actually is. We would just give you a gist on where it is used and how it is used and what opportunities you can get, and then we would give a small intro to Anaconda and Google Collab, and then we will introduce you to Numpy, Pandas, Matplotlib, and Cbon. These are some libraries in Python which is used in machine learning, and we would give you a brief introduction to what are the types of machine learning algorithms, and we would discuss the very basic concepts of four algorithms: linear regression, logistic regressions, support vector machines, and KNN. So, introduction to machine learning. Well, what machine learning is? Machine learning is the study of computer algorithms that can improve automatically through experience and by the use of data. So, in a nutshell, if you have a problem and you are able to collect data about the problem, there is a very good chance it is a machine learning problem and can be automated easily. ML algorithms build a model based sample data known as training data, and ML algorithms are only known to get better over time. So the more and more these are being used, the more and more good your model will be. So roadmap to learn ML. Well, a very rough roadmap to learn machine learning would be to start with a programming language. It is best to start with Python and R, because there is a very good open source community with lots of libraries in existence. So because of this very active support, Python and R are very powerful. We would be doing Python today, and the mathematical basics, which is linear algebra and statistics. And the third step is to learn core machine learning algorithms, some of which we will be discussing in the later on session. And the fourth one is to learn to deploy them. And some common examples of machine learning problems are facial recognitions, like recognizing patterns, and generating patterns, like generating images or generating motion sequences, and recognizing anomalies, like understanding unusual patterns of sensor readings, maybe marking an email as spam or not, that is an anomaly, and predictions, like predicting stock prices, future stock prices, and future forex rates. Applications. Well, where do we use this? We use it practically everywhere, but we don't realize it. Some very common applications of ML is in web search and debugging software, although code companions which come as extension in our code editors are based on ML, and we use it in computational biology. It is also used in finance and e-commerce, space exploration. It is used in astrophysics too. It is used in robotics. It is also used in information extraction. So what is the advantage of machine learning? Well, the very best advantage is you can automate almost everything around you. The only catch is you should collect enough data for that, and it can be applied to a wide range of applications. Like one general solution can be applied to many different problems, unlike software, which has to be tailored specifically to each and every single problems. And with machine learning, you can efficiently handle data. So handling data with machine learning is the best, and easily identify new trends and patterns. Machine learning is the best in pattern identification and identifying new trends. So what careers you can make out of in machine learning? Well, if you learn machine learning, then you will have lots of jobs in the industry. Very popular ones are machine learning engineer, a data scientist, a business intelligence developer, a human-centered machine learning designer, and a natural language processing scientist or an NLP scientist. So Anaconda and Google Collab. So you be introducing you to Anaconda first. Anaconda is just another Python distribution that is commonly used for data science. Anaconda distribution has lots of useful tools such as Jupyter Notebook, Spider Notebook, stuff like that. And Google Collab is yet another place where you can write code, but this is completely based on a browser. You have to install nothing with Google Collab. And with Anaconda, you get Jupyter notebooks. We will be running all the code on Jupyter. We will introduce you to that. And next up, we will look into the libraries we use for machine learning. So one such library we're going to look at now is Numpy. So what is Numpy? Well, Numpy is the go-to library for scientific computing in Python. So Numpy is centered around a multi-dimensional array object called ND-array, and this has lots and lots of features and attributes. We use NumPy to handle large amounts of data. NumPy is more or less like lists, but much efficient than those when it comes to handling lots of data. So yeah, let us see the coding part of the session. So we would take you to NumPy. Yes, so just like any other Python libraries, we use the import statement. We import NumPy library as NP. Why NP? NP is just an identifier. We can import it as anything, but it is convention to use NP. So how do you initialize a NumPy ND array? Well, first of all, I want to make sure the screen is visible. Are you able to read the code, right?
Yes, we can see the code.
Okay, cool. So initializing a NumPy array, well, you can initialize arrays of different dimensions. Like we are not restricted to any specific dimension. You can initialize arrays of 4Ds and 5Ds, but initialization gets a bit complex. So we just took the first 3 dimensions over here. So if you want to initialize a 1D linear array, you can do so by calling np.array method, and as an argument you pass a single list in which you will give all the entries you want as the data values. And for initializing a 2D array, we would be giving a list of lists in this manner, and this will initialize a 3 by 3 matrix. And yeah, each and every single entry of this specific array, which is B, would be of data type double, because I've explicitly specified it by passing in an optional argument which is called a D type. And in a similar fashion, you can also initialize a 3-dimensional array. So let me print all these out so that you can see how they look like. Yeah. So as you can see, the 1D array is a linear array, 1, 2, and 3, just like we wanted. And the second one, the second 2D array, is a 3 by 3 matrix, which is exactly what we expected. And the third one, C, is a 2 by 2 by 2 3D array. So the convention is pretty confusing, but if you work on it for a long time, if you get used to it, it'll be pretty easy. So this is how we initialize an NumPy array, and let us look at the different attributes of these NumPy objects. So the first attribute we are going to look at is the shape. So each and every single array has their own shape. What do we mean by shape? Well, our array A had 3 entries and it was of a linear dimension. So we have its shape to be 3. And the second one had 3 elements, 3 rows and 3 columns. So our shape would be 3 by 3. And the third array we declared was a 2 by 2 by 2 3D array. So this one will give you a shape of 2, 2, 2. So how do you know the shape of the array? Well, just use the dot shape attribute and you can get the shape. So the next attribute we're going to discuss is the dimensions of these arrays. So if you want to know what is the dimension of a given NumPy array, well, you can do that by calling the .ndim attribute. Ndim is will return the dimension. So as we saw, A was a 1D array, it gave us 1. B was a 2D array, which gave us 2, and C was a 3D array, so the dimension was 3. And the third point, and the third next attribute is the element size. So let us say you have an array, you want to know what is the size of each and every single, it's the size of each and every single entry. So how do you do that? You do that by calling the dot item, you call by dot item size. So if you remember, guys, A and C, everything was a 32-bit integer. By default, it gave us 32-bit integers, and B was a floating point value, that is a double value, which I have specified using the .dtype method. So similarly, it is occupying 4 bytes, 8 bytes, and another 4 bytes. So the next one is the data type. Well, each and every single array has its own data type, which has stored inside. So to know the data type of these elements, you just simply call the .dtype attribute. So how do you do that? By simply the name of the array .dtype. So as we declared, the first one was a 32-bit integer, which is A, and B was of 64-bit floating point value, which is also double, and C is again 32-bit integers. So the next attribute we're going to look at is the total size. Well, if you want to know the total size of a NumPy object, so you do that by simply calling the .nbytes attribute. So if you do that, it returns the total size of each and every single array object. So this is the total size attribute. And the next up is the number of elements. So we want to know what is the number of elements in each array. You call that by using the dot size attribute. So a dot size gives you the size of A dot B gives you the size of B, C dot size gives you the size of C. So what this size basically does is it returns the number of elements there in that specific array. So yeah, these are pretty much all the attributes of a NumPy array. So next up, we will look at some basic array operations and slicing. And to access a specific row, you can access specific places of an array. Like for example, you want to access an element of row comma column method. So B is a 2D array. I've printed this out. So as you can see here, its index starts at 0, 1, 2, 0, 1, 2, and you get the array. So if you want to access this specific element at index 1, 2, which is 0, 1, 0, 1, and 2, which is 6, you can do so by using this notation, B square brackets, and you give the index of where you want to access it. So in this case, 1, 2 will be 0, 1, and again 0, 1, and 2, which is 6. And this is accessing a specific entry. So if you want to access a specific row, we are using the example of B, this matrix over here. So if you want to access a specific row, you can do so very similarly to how we would do with lists in Python. So I'm accessing the very first row over here. This very first row starts with the index 0, and I want each and every single element in the column. So for that, we use the colon notation. So we access this row and every single entry in the column. So it will be 1, 2, and 3, and that is exactly what we got. And to access a specific column, it is the same thing, but in the opposite way. So you have accessed the third column or the second index. So it will be 3, 6, and 9, and that is exactly what we got over here. And to replace values, this is the last array operations we're going to see. So if you want to replace a specific value, so initially B was of this sort 1, 2, 3, 4, 5, 6, and 7, 8, 9. So let us say I want to replace the value at 0, 1 to be 3. So I do that explicitly by this notation. I'll give B square brackets and the index, and I will assign it the value which I want to do. So when you print it out again, you get this array. So initially it was 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it has changed to 1, 3, 3, 4, 5, 6, 7, 8, 9. Yeah, and that is pretty much some basic introduction to the array operations. And we would look at initializing some special arrays. So we can initialize a lot of special arrays. So we'll go for zero matrix. So if you want a zero matrix in NumPy, you can do that by calling np.zeros. And a small reminder, we imported NumPy as np. So np.zeros, and you pass in the shape as an argument, you will get a beautiful zero matrix of the required shape. So here I have passed in 3 by 3 shape. So I got a 3 by 3 zero matrix. You can do the same thing for ones matrix, just the name of the function changes to ones. So np.ones and pass in this shape, you would get a 2 by 2 ones matrix because we pass in 2 by 2. And after that, you can also create an identity matrix. So identity matrix is already a square matrix, so no need to pass the shape. Only thing we need to pass is the order and the data type if it is required by using the d type argument. So I have passed in the number 4 over here to this np.identity function. So this gave me a 4 by 4 identity matrix. And next up, filling an ND array, a NumPy array with a desired number. Let us say you need an array of a specific shape and you want each and every single entry to be a specific number and the entry to be of a specific data type. You can do that by calling np.full. So what are the arguments it is going to take? It takes 3 arguments. The first one is the shape. The second one is the number which you want it to be filled with. And the third type is optional. It is a data type. So I've just given the 32-bit integer to be the data type. And yeah, as I required, I needed a matrix, 3 by 3 matrix with all entries to be 66, which is of type int. So I got it. Yeah. And next up is filling up a matrix with a random numbers. So let us say you want a random number matrices or random number anything for that matter, a random number array. So how do you do that? You do that by calling np.random.randint. And what are the arguments you're going to pass to this function? 3 arguments actually. The lower limit, the upper limit. This upper limit is exclusive, and the size. So I've given the size to be 4, 4. So 4, 4 will basically give me a 4 by 4 matrix in which each entry is between 6 and 9. 9 is exclusive. So yeah, accordingly I've got the output over here, which is correct. And the last thing is populating with a matrix with a random decimal. So if you need a NumPy array with random entries, you can do that by calling np.random.rand, and as an argument you would pass in the shape. So right over here I have needed a 2 by 2 matrix, so I just passed 2, 2 as the entry. So I've got a 2 by 2 matrix in which all entries are random numbers between 0 and 1. And that is pretty much a small introduction to the special arrays in NumPy. So let's go do some basic math with these. So mathematical operations, just like you would do on Python, you can do it here. So let x be 1, 2, 3, 4, 5, this small row vector. So I can do all the basic math operations, like x plus 2 will add 2 to each and every single entry, and x minus 2 will take away 2, subtract 2 from each entry. And I can even raise those with the power 2 by using this notation as you would do in Python. You could also do some trigonometry with this array. So let us initialize an array y with 1, 2, 3, 4, 5 as these entries, and you can take the cosine of all these values by calling np.cos and pass in your array as an argument. So as you can see, the output over here is the cosigned values of all these inputs. And you can also do some matrix multiplication. How do you do that? Well, you call the matmul method, which stands for matrix multiplication, np.matmul, and pass in the two required matrices with which you want to multiply. So over here I have a ones matrix. A is a ones matrix of type shape 2 comma 3, and I've printed it out over here. You can see the shape. And B is another matrix in which each and every single entry is 2, and I've printed it out over here so you could see. And the C is what I'm going to use to store the result of the multiplied matrix of A comma B. So if I print out C, as you can see, when you multiply these two matrices, this is the product. This is exactly what you would be getting. And yeah, that is matrix multiplication. And next up is a linear is to find the determinant of a matrix. So if you want to find a determinant of a given matrix, you do that by calling np.linalg.det of C. Linalg is a short form for linear algebra, and det is for determinant. And for C is a square matrix in which each and every single entry is the same. So the determinant should be 0, and yes, it is 0. So next up, you can also do some basic statistics with these Numpy arrays, but we'll not get into that right now. So array reshaping, well, yeah, this is a crucial concept. Like you can reshape arrays however you want. So in this case, we have an array A, and the shape of the array is 2 comma 4. So if you want to rechange the shape to something else, you can do that by calling np.a.reshape method. So you would pass in the required shape you want, and you would call the function on the object. Like on A, I've called a.reshape, and I've passed in the new shape. The only catch is the new shape and the old shape must have the same number of elements. So if that is not the case, you'll get an error. So this is a 2x4 matrix. Like, yeah, I've changed the shape of this matrix into a linear matrix by using this method. So this gave me a linear shape, and I've converted the same 2D to a 3D by using a.reshape and 2 comma 2 comma 2. So as you can see, this has 8 elements over here, and B is 1 comma 8. So 8 times 1 is 8. So the number of elements, that criteria is satisfied. And same applies for C. C is a 2 by 2 by 2 3D matrix. So 2 times 2 4, 4 times 2 8, and you got the same shape B. So next up, this is a brief introduction to Numpy. So if you want to learn more about Numpy, I would highly suggest you to check out the official documentation page that will provide lots of information. Next up, we would go to Pandas. Yes. So what is Pandas? Well, Pandas, we are talking about that fluffy animal. This is a software open source Python package which is mostly used to handle big amounts of data with ease. So what we'll cover today is some pretty basics of Pandas. We would try to load data from different formats to Pandas. We would be reading the data, we would be modifying those data, and we will also be saving whatever modifications we did. So let's go to the coding part. Yeah, so just like Numpy, Pandas can be imported however you want, but by convention we import it as PD. And to load our data, so before we load our data to Pandas, we would actually have a look at what data we are going to handle. So I would show you. We are having the data of around 5,000 metal bands, and this is how the data looks like in an Excel form. So as you can see, it is all messed up, and you have lots and lots of entries, and it is not possible to do all of this by hand. So this is where Pandas comes in. So we'd be importing them. I mean, we'd be loading these data onto Pandas. So how do you do that? Well, you do that by using pd.readCSV method. So if you're going to load a CSV file, you would basically load it into Pandas by calling pd.read_CSV, and as an argument, you would pass in the file name. And if your file is not in the same directory as where you're operating this, you would have to pass in the specific directory path. And if you want to open an Excel file, it is the same criteria, but instead of read_CSV, we would go for read_Excel. You can also open lots of different files of other formats like tab separated values, text, or SQL, but we would be sticking to these two formats, and we would be using the CSV file to do all the modifications. So df is where we have loaded all our data to. So how does this look like? Well, this is how our data looks like. We have 1, 2, 3, 4, 5, 6, 7 columns, serial number, the band name, and when number of fans, and when was it formed, and where was it originated, and when did they split up, and what are the style of music they're going to play. So this is the data we are going to be dealing with. So around 5,000 rows and 7 columns. So to read the data by header, like we want to know what is the column header of each and every single data. So you just do that by calling df.columns. And again, df is where we have loaded all our data to. This is the name of the variable. It can be anything. Since we have loaded the data into df, we are calling df.columns. So as you can see, as the output, it has returned the list containing all the columns, and it has also returned the data type of it, which is a custom object, which is understandable. And next step is to reading data. And to read each column, you do this, like you call df, within double square brackets you pass in the required column headers as arguments. So I want to read the band name and the fans alone of my data. I just do that by calling df double square brackets, and you pass in these two. And as you can see over here, from this initial data, I'm only reading the band name and fans. So yeah, just band name and fans over here. And next up is to locate a data point using Ilock function. So what does this do? Well, this statement over here, print df.ilock of 0 to 5, 0 colon 5. So if you're familiar with this, you would have got the gist of what is going to happen. So this statement will give me all the data points between the index 0 to 5 not excluded. So as you can see over here, I've got the zeroth entry, first entry, second row, third row, fourth, and the fourth row. So this is how you use Ilock functions to read rows, the required rows. But say you want to access a specific element using Ilock function, you do so by passing in the exact index. So df.ilock of 2, 1 will give me the data value at the second index, the second row, 0, 1, 2, and the first column, which is Metallica. So that if you see down, yeah, this is exactly what we got. And this is Ilock function, a small introduction. And next up, we would be reading data with iter rows method. So reading data with iter rows method is pretty easy. So we just give a for loop, for of index comma row and df.iter rows. This will iterate the data frame by rows, and you can print out the index and the specific row you want. In this case, I've taken a simple example of just one row, but you can print out many rows too. You just have to pass in the required rows as a list to this data frame. Yeah, and that is iter rows. And I just pass in something else so that you can see. Yeah, so now it is reading the index and the number of fans of each and of the data frames we have. So we would stick with band names, so a lot of numbers are confusing. So yeah, as you can see, we are getting the index and the band name from the data. And next up is the lock method .lock. So if you want, this is basically used if you want like a conditional reading of data. So let us say this is my data. I want all the data points in which the number of fans is greater than or equal to 1,000. I do so by calling the lock method. So the syntax is df.lock. And again, a small reminder, I've loaded all my data to a variable named df. So df.lock, and within square brackets, I give what I want to do. Like in this case, I want the number of fans to be greater than or equal to 1,000. So I specify the condition over here. You can specify many conditions, but for the sake of simplicity, we have done this. And this is reading data with .lock. And next step is to describe data. Like we have some numbers over here. We have the number of fans, and we have when they were formed, and we have some numbers. So you can do some statistics, right? Basically, if you see numbers, we try to do statistics. So to do that, we use df. To do a simple version, we use df.describe. So what this returns is, it returns the count, it returns the mean, it returns the standard deviation, and the 5-point summary, which is the minimum, 25th percentile, 50th percentile, 75th percentile, and the maximum of the data. So it has returned all these of S number and fans for us. df.describe has returned this because in each and every single entry of these were numbers, so it has returned it for me. And this is pretty much reading data, the basics in Pandas. So next up, we would see how to modify them. Yeah, so you can sort data values by, let us say, by using sort values method. So df.sort underscore values. This will help you to sort values. So I'm sorting this data in such a way that I want the number of fans to be ascending. So in this data, as you can see, okay, ascending, I'll run it again. Yeah. So in this df.sort values of fans and ascending equals 0, I've set ascending to be false. So this should give me all my data in descending order, and I've done it for the number for the data entry fans. So you can do it for anything, but since this is a number, I've given it for the sake of convenience. And this is sorting values in this way. And you can also drop columns. Like if you want to remove a specific column, like you can see over here, Pandas gives its own indexing, which is at the leftmost side of our data, 0, 1, 2, 3, 4, and 5. And we have one more S number over here. So this is also indexing. So let us say I don't want this, so I want to remove it. So I can do that by dropping the column. So how do I do that? I use df.drop. And again, df is the name of the variable I've loaded my data for. I've loaded my data to. So I've called the drop method. And as an argument, I would pass columns equals a list of all the columns I want to drop. So I would give the S number because I just want to drop that. So if I execute the code over here, you can see S number is no longer there. It is gone. So this is how you drop columns in Pandas. And adding new columns, well, let us say I want to add a new column in which I would take the relative frequency of fans, which is basically I'm adding up all the number of fans, I'm dividing it up by the total fans. So in this case, I do that by using simple Python code for loops, and I get the total number of fans in this variable over here after running this code. So I need a new column. So I simply do that by calling it. So df within square brackets, I give the name of the new column, and I will set it to df of fans, which is this column divided by total number of fans. And when I print it out, as you can see at the end over here, we get this new column fans ratio, and it was not there before. And next up, we would be rearranging these columns. You can rearrange it explicitly by passing a list of how we want the columns to be rearranged, like so. Within double square brackets, you just pass on all the column headers as lists in the order you want, or you can use the list slicing notation in Python, which is normally used to do it. And to get the list of all the column headers, you can use df.columns. Df.columns will return the list of all column headers, and you can convert it to a list by using the list method. And yeah, you can rearrange columns in this way. And at last, we have done so much of work. So to save our work, we have opened two files, right? We have opened a CSV file and we have opened an Excel file. So to save our work in a CSV file, we just call the .toCSV method, and then we'll given the file name, and we'll pass on one more additional parameter called index. Index is equal to false. Remember, I said Pandas automatically gives an index. So if you don't want that to be saved in the file, you have to specify index equals false, or else it will also be saved. So I can execute this, and this will be saved in the same directory in which I've opened pandas into. And for Excel files, instead of CSV, I'll use underscore Excel. So yeah, that's pretty much saving your work in pandas. And thank you. I would further hand over the session to my colleague Khushi, who would be taking further.
Can you guys see my screen? Hello, am I audible?
Yes.
So I hope you guys can see my screen. Hello everyone, my name is Khushi. I am from CAC BDA B section. I'm a second year student. And I'm here to take data visualization in machine learning. This is more of the fun part of machine learning. We're gonna see a lot of colors and images, etc. But why do we need it, and what exactly is data visualization? So basically, it is the graphical representation of information and data. So when in real life, when you're working with machine learning, you're going to have huge amount of data sets, right? So to just visualize the data set, let's say someone who is not very tech savvy and comfortable with thousands of rows and columns in an Excel sheet, how will they analyze data? That's when we use pie charts, bar graphs, and etc. to visualize the data in a pictorial format. And this also helps us to interpret the data faster, right? Instead of going through each and every row and taking out the data, you can just have it in a pie chart like this or a bar graph, and you see there's growth or there's decline, etc. Daily examples is trends of stock markets. I'm pretty sure you guys have seen the decline of Bitcoin and the increase in growth and stock rate, etc. GDP trends, pollution rates of different cities during different years, etc. So today I'm going to teach two tools that we use for data visualization. The first one is Matplotlib. This is a library from the Python programming language, and it is based off on Numpy. Hopefully you're familiar with Numpy now. So what Matplotlib helps us with is two-dimensional graphics. This is the same as what we learned in school: bar graphs, histograms, line graph, but in a digitalized format, right? So this is what Matplotlib is. There are 6 types of graphs that we can go through in Matplotlib. These are the 6 types of graphs. But today I'm only going to cover on the first 3, since it's a very basic session on machine learning. So bar graph, histogram, and scatter plot. So I'll get into my Jupyter notebook and I will explain. So this is Matplotlib. So the first is the line graph. Okay, so first we'll import matplot library. From just like NumPy, we import it as an NP. We import matplotlib as PLT. You can import it as anything, to be honest, but since you know how the first line of code is always hello world, conventionally the same way you import this as PLT, right? So now we'll plot and execute a graph. I have named in my variables X and Y. I have asked my code to PLT plot my variables X and Y. So since Matplotlib is based off on NumPy, you can only have your variables as array or scalar, basically numerical values. Okay, and now I have asked it to execute plt.show parentheses, and this is how your graph will be executed. Let me say, I'll just change these values a little bit so that you guys get a hang of it. Put it as 1, and I'll shift enter, which is to execute the code. This is what your graph will look like. So you can put in any types of variables, it doesn't matter, right? And then you plot it and you execute it. But what does this graph actually tell us? Absolutely nothing. We don't know what we're talking about. We don't know what our x-axis is. We don't know what our y-axis is. And that's when we use the code plt.title to call out the title, plt.xlabel. This is basically naming the x-axis, and Y label, naming the Y axis. For convenience, I have named it horizontal and vertical for the example, and I've executed. And this is the graph. We have our X axis name, we have a Y axis name, and we have the name of the graph itself. Let me just copy paste this code into the previous graph and show you how it will look. This is what it looks like. The previous graph, we did not have any names, but now we do, right? So this is a very basic syntax of how to plot a line graph and name it. Right, moving on to, obviously this was very basic. Now I want to have more lines than just one. I want different colors, different width of the line. I want to customize the graph the way I want it to. And so for that, after importing pyplot as PLT, we'll import style from Matplotlib, right? Style.use ggplot. So ggplot is a type of style. There are different types of styles. The documentation of this will be shared with you in the chat box, right? So now I've called in 4 different variables, because I wanted 2 different lines. So my x, my y, my x1 and my y1, plt.plot xy. Until here I've already covered in the previous cell. So what is this? So first one, I call out the color green. Okay, this is the line that we're talking about. What the graph shows, I'll get to that first, right? So this is the weight of a dog, and this is the age of the dog, and how their weight increases as their age increases. This is hypothetical data. This is not a true data set. So this is for male dogs, the green line, and this is for female dogs, right? So I wanted the color to be green. I've labeled it male dogs. What does it mean to label? This is the legend. I hope you guys remember this from school. So this tells us what the line is actually about. So if someone's not looking at the code, they should be able to make out which one is male, which one is female, right? So that's why we have label M dogs, line width to be 5. The line width of male dogs is 5. Let me just change it to 15 so that you guys know the difference. So you guys have seen this has gotten a little thicker. So that is what line width means. It's gonna change the width of this line. Then line style to be dashed line like this is. So if I remove this bit, okay, and I execute my code, this is gonna come as a straight line, but I don't want it to be straight. I want it to be dashed. So I have a dashed line. Now plt.plot x1 and y1, these are my second set of variables. B, what does it mean? That means blue. Even here, if I had it as green, and I would have had it as G instead of green, and I run the code, I will still get green, right? So basically what this means is for our convenience, we can also put in just the starting alphabet of a color. So I've put in green and blue. I've labeled it female dogs, and my line width here is 7. I've given the title, my x-axis, my y-axis, I've named everything. Plt.legend, this is to execute our legend. This is the legend. Let's say I forgot to put this in and I run my code. I won't have the legend. We will have the labels, but they'll be in the backend. That will never execute itself, right? Now, what is grid color? Grid color in the previous graph you may see, this is by default white in color, but I don't want it to be white. I want it to be the color I please it to be. So now I have yellow. I could have put black as well. I could have put orange. So for black, the K is a short key. And you see the grid lines are now black in color. And now I executed my code. I hope this is clear. If not, you guys can put in your questions in the chat box. My team will be there to answer and help you. Now we'll move on to bar graphs, right? Again, import Matplotlib as PLT. Now, instead of naming my variables X and Y, give them values, I will directly put in my data here. I can also would have X is equal to so-and-so, Y is equal to so-and-so, PLT.bar X and Y, or directly put in my data. Okay, it doesn't matter. And the line graph, I hope you guys remember it was PLT.plot. Since it's a bar graph, it's PLT.bar. My X is here, my Y is here, I've labeled it, right? And this is for the second type of bar. X is here, Y is here, the label is here. And I've added a different color to it, right? Because I want it to be the color I want it to be. The default color would have been blue and red, but I didn't want it to be blue. Wait, let me just show it to you, right? The default color would have been blue and red, but I wanted it to be in yellow color. So I had put in my code to be yellow and I executed and it's yellow in color. Now I can also customize my x-axis, my y-axis, and the title. So for now, I've called out my font dictionary, font name to be Comic Sans MS. Again, there are a lot of fonts that you can go along with, and my font size to be 50. Let's just say I put in my font size to be 20, and you see this is 50. And when I run the code of 20, this is what it'll look like. And you can also change the font name. You can also change X and Y axis just so that there's not a lot of code on the screen. And I didn't want to scare you guys. So I'm just going to stick with just customizing our title. I call out my legend. I execute my graph. And this is the final result. The name, the legend, the different colors, the data being interpreted as a bar graph. Simple and easy. Now let's move on to histogram. Okay. Again, import matplotlib as PLT. Now, again, this is my X, population ages. I've given my X to be a random set of data. This is my Y, bins, and I have flipped. What bins actually means is, so when you see a bar graph, it's 1, 2, 3, 4. But in a histogram, if you guys remember, these are categorized. So everything from 0 to 10 will lie here. It's not 1 separately, 2 separately, 3 separately. It's 0 to 10, 10 to 20, 20 to 30, so on. It could have been 0 to 5, 5 to 10, 10 to 15, but so that it's not a very big confusing graph, I've just put in as 0 to 10 to 20 until 50. Now plt.hist for bar graph it's plt.bar. I've called in my histogram, my X, my Y, my hist type to be bar, and my width to be 0.8. What width? The width of the bar. Let's say I put it as 0.2 and I enter. This is what my bar will look like. I hope this part is clear. I've called in my title, my x-axis, my y-axis, and I've executed the code. So this is what a basic idea of a histogram using Matplot would look like. Okay. Now scatterplot. This is the last part of Matplotlib, but I also will be using a scatterplot in the next session. So make sure you're clear with this. Import Matplotlib as PLT. I've called in my X and my Y variables. I've called in plt.scatter, my X and Y. I've labeled it skitscat. I don't know why. My color is black. Again, it can be any color you want. And my marker is O. meaning again I can have different markers, but I just want it to be points, so I've put in my marker to be O. My title is cat. I guess you can see that here. It's cat. My x-axis is named x-axis and my y-axis is named y-axis. Again, I could have changed the names. I could have customized the size, the font style, anything. But I wanted less code to be on my screen. So this is what it looks like. Let's say I taken the x and y. Okay, so the first coordinate is x1 and y5. x1 and y5. So this is where it is. And let's say my last one is x6 and my y is 3. So my x is 6 and my y is 3. So this is where it is. So why is scatter plot different? In histogram, bar graph, line graph, everything is continuous. It starts from 0 and goes in ascending orders for x and y axis, right? But that's not the case with scatter plot. In scatter plot, the probability, like, it's distributed throughout your graph. And we'll see why exactly is this useful in the next session. So we're done with Matplotlib here. Again, if you have any doubts, put in the chat box. I'm pretty sure there'll be a documentation link. So Seaborn. Seaborn is another type of visualization tool. Why do we prefer Seaborn over Matplotlib? Because when the number of parameters increase, so in the dogs, the male dogs, the female dogs, we had the weight and the age, and we also had the gender. But let's say I wanted to see if the dog was a vegetarian or non-vegetarian. I wanted to compare if they are domestic or stray dogs. Where will I fit all these parameters in a two-dimensional graph? That's when we use Seaborn. So in Seaborn, the graph can be 2D, 3D, 4D, 5D, and so on. You can't have that in real life. It can only be, visualized digitally. So the graphics, the Seaborn graphs are graphic, okay, and they usually helps in exploration and understanding the data. I will now go into my Seaborn Jupyter notebook. Okay, so we're gonna learn distribution plots. We're not gonna, okay, first of all, import Numpy as NP, Pandas and PD, and Matplotlib as PLT. I hope you're comfortable with this part of the code by now. Okay, and now I will import Seaborn as SNS. Okay, so what we do in Seaborn is we deal with data sets. In Matplotlib, we dealt only with 2-3 variables, or maybe like 5-10 variables. But here you're gonna deal with huge number of data sets, like in Pandas, right? So I'm gonna call out an inbuilt data set, and it's called tips. So my DF stands for data frame, is equal to SNS, Seaborn that is, load data set, and the name of the data set is tips. And so to call out the data self itself, df.head parentheses, this will call out by default the first 5 rows of your data set. But let's say I wanted to call out the first 100 rows of my data set. I'm just going to go ahead and put in the number 100, run my code, and it's going to be from 0 to 99, which is 100 rows. Okay, so first let's look at the data set and let's see what you're gonna make out from this, right? So we have total bill, we have tip, the sex of the person, is that person a smoker, what day of the week did they come in to have the food, what time of the day did they have the food, and what was their portion size. Okay, what we have to do from now is we have to take in all these parameters, okay, total bill and sex, smoker, day, time, size, and make out how much tip would they have given, right? So obviously their gender, if they smoke or not, when did they have it, was it lunch or dinner, that wouldn't matter, right, to the tip. Maybe what was their total bill, how was the service, what portion size did they have. Maybe if there was another column called occupation, so maybe that would have depended how much they earn and how much they can spend on a tip, right? But this is a very basic data set. So now we're going to compare these parameters and see how much tip they would have given. Okay, this is just for your understanding. You don't have to execute this. DFD types. This shows us the data types. This was discussed in Numpy and Pandas by my colleague Disshad. So what we're going to do is call out the data types, and we're only going to deal with floating point values and integer. For those who are not familiar with Python, what float means is decimal values. So total bill is float and tip is also float, right? Total bill is decimal values, tip is also decimal values. What size is an integer. Obviously, you can't have 2.5 portion sizes or something. It has to be a whole number. So this is what your data types is. What you're going to do is you're going to compare floating and integer and see how much does one parameter affect the other. How much is one variable dependent on the other, right? So now we'll use a heat map to correlate how much dependence is there. So first we're going to call out data frame correlate, meaning what values of the data set can depend on the other variable. So if you take out the proportion of total bill and total bill, obviously it's going to be 100%, right? 1:1 is 100%. But let's see how much this total bill depend on the tip, and that is 67% or 0.67, right? How much this total bill depend on the size is 59%, meaning total bill depends more on the tip than it depends on the size, because 67% is clearly higher than 59, right? I hope you guys get the idea of what you do with correlating different types of parameters. So I will call in a heat map, sns.heatmap of data from the data frame of the values that we have correlated, and this is the execution code. So this is what a heat map looks like. This is a very pixelated heat map. Okay, this is not what you'll be dealing with in real life, but again, I don't want to scare you guys. So basic heat map. So this is the scale of the heat map. The lighter the shade is, the more those values correlate. As it keeps getting darker, the relative correlation between the two parameters is lessened, right? So total bill and total bill, obviously it has to be the lightest because it depends 100%. But if you see how much this tip depend on the total bill, the color is lesser, meaning it correlates lesser compared to the total bill depending on the total bill. Now, if you see size, how much does size depend on total bill? It's much darker because it depends lesser compared to the tip. I hope you guys get the idea of this. Okay, if not, if you want me to repeat, please let us know. We'll move on from this and we'll go to joint plots. What joint plots is executing two different types of plots at the same time on the screen, comparing two different parameters. Now I've taken my parameter to be tip and size. Okay, again, just I could have written x, y here, put in, and then just called in x and y, but this is more convenient. I've called in my two parameters. I have told what data I want is from the data frame I was using before. And the kind of graph I want this time is a scatter plot. So I've put in kind to be scatter. There are different types of plots, okay, in kind. I'm going to discuss that as well. I've executed. Now I have a scatter plot with a histogram. The histogram is by default. So this I hope is clear. Okay, so two different variables, comparing them with two different graphs. And moving on. This is again a heat map, but the kind is hexagonal. Okay, when the scale of a heat map, if it's not mentioned like it was mentioned before, what it means is the darker the area is, the more that thing correlates. Meaning, if you compare total bill and size, if the total bill was 15, let's say dollars, the most tip given was $2. If it was lesser, if let's say if total bill was 40, the most kind of tip was given was $4. I hope this bit is clear. I hope what a heat map is clear and how we use it and why we use it. Honestly, even if you don't understand, it's understandable because the data set is huge. We're not going to go and learn each and everything and understand each and everything, right? But this session is just to familiarize you with what you'll see while taking machine learning as your field. Now, pair plot. Pair plot is this. What it actually is comparing different parameters using different graphs at the same time on your screen. Usually you use this type when you don't know what you're expecting out of your graphs, right? So you just compare everything using different graphs at the same time on the screen, hopefully so that you can make sense out of the data set you've put in. So SNS pair plot of the data frame, SNS set, the style is dark grid. Okay, again, different types of style, the documentation will be shared with you. So here I've used histograms and scatter plots using comparing total bill, tip, size to the same parameters. I hope this bit is clear. If you don't understand, I just hope you a little familiar with what machine learning would look like. Now let's just say I wanted to add another parameter to this. Okay, I wouldn't have been able to do that with Matplotlib, but I've added another parameter. Let's say the sex of the person, and now the male, female. This is the area probability distribution, scatter plots. I could have put in, let's say, smoker here. I run my code. Take a while. Here. Are they a smoker? Yes. Are they a smoker? No. And this is what the graph would look like. Okay, this is the end of the session from Seaborn as well. If you have any doubts, please let us know. Now we'll move on to types of algorithms, right? There are two types of algorithms, supervised and unsupervised. In supervised, what you do is that you give an input, to your algorithm. You tell what you expect as an output, but the algorithm does all the work. I'll give you an example. This is like a typical max textbook, right? They give you the formula, they give you the questions. At the end of the book, you have your answers. But all the devising the answer, the process of getting the answer, you have to do it. Same way, a teacher guides a student. He or she gives in the input throughout the year. What output is expected, what result is expected, also is said to the kid. But the kid has to go through, all the hardships of getting that result. What unsupervised algorithm is, you give in your input, but you never guide it to where you want to go. That's like telling me to go and cook. I know the materials are available, but I don't know how to cook, what to cook. I'll just make up something. I'll come back and I'll ask them if it's too spicy, if it's too chewy, if it's even edible. So what happens is they'll give feedback. I'll work on it again, and that's what the algorithm does. It gives in the output it thinks is the best. We give in the feedback. Based on the feedback, it'll give us another output, and then again feedback. So basically, it works on feedback mechanism. It keeps going back and forth with the feedback in the output until you are satisfied with what the algorithm has provided you. We're gonna see 4 different types of algorithms today. Okay, so no more code, just theoretical bits and a little bit of math, but we're not gonna do the math, so I think you're fine. So the first one is linear regression. Okay, what you do in a linear regression is usually you deal with scatter plots. Okay, so when you look at a scatter plot, you never know what it's actually telling you. It's not like a bar graph, it's not like a histogram, it's not like a line graph, it's not like a pie chart, like it's just all over the place, right? So when you have a scatter plot, you need to know where the plot is taking you. And for that, we use this thing called best fit straight line. Okay, so we use dependent, independent variables and we find out the best fit line. So this is a supervised machine learning algorithm. Okay, so the dependency of labels X and Y has to be linear. This is how do you find out the line is y is equal to mx plus c. I hope you guys remember this from school. If you don't, I'll tell you what it is, right? So basically, this is like taking the mean of all these points and putting it in a straight line. So the y is the slope, the c is the intercept. If you don't know what an intercept is, if your x-axis is 0, where does your y lie? If you take this graph as the example, your y is at 1. So this is your intercept. Your c is 1. M is the gradient, which is the rate of change. So let's say this was a stock of, let's say, Johnson's and Johnson's, right? And if there's a dip, see, thousands of people buy the stock, thousands of people sell the stock. But we only see straight lines in the news channels when they show us if the stocks have declined or increased. How do they get that? They take a scatter plot, they put in linear regression algorithms, and you get the lines. So it tells you if the rate of the stock is increased or decreased. The second type of logistic regression, second type of algorithm is logistic regression. This is basic. For example, I ask you, did you have lunch today? The answer is going to be yes or no. I don't care what did you have. I don't care when did you have. I don't care how much you had. Yes or no. So this is also a supervised learning algorithm. Okay, so if it's a yes, it'll go in here. If it's a no, it'll go in here. For example, Google. Whenever you receive a mail, what Google will do is it spam or not spam? Simple, yes or no. It doesn't matter how much content is there, when did it reach you, who sent you. Is it spam? Yes. If it's not spam, no. If it's not spam, is it primary? Is it social? And so on, right? So that's what logistic regression is. See, it is used when dependent variable is categorical. Means that there's supposed to be 2 categories. Yes, no, that's all. It has to be categorical. At the end, you find a sigmoid function. Okay, so this is, let's say again, yes or no. If this is done, there's a sigmoid function. And I hope you guys understood this. I hope you're a little bit familiar with logistic regression and basics of machine learning. Now I'll pass on the platform to Disshad to take it from here.
Hello guys, so welcome again. So yes, so we would be dealing with 2 more algorithms. These are classification algorithms, also supervised. So we'll look at what a support vector machine and what a k-nearest neighbor is. So support vector machines are just another supervised machine learning algorithm, but this is used to classify data. Like in this example, you can see over here, in this data way, you have 2 types of data. You have red and you have blue. So naturally, the question arises like, given a point on this graph, how do you know it is either red or blue? So this is a training data, meaning the initial data we fed to the algorithm. So I want to classify a never before seen point as either red or blue. So naturally, by looking at this, they are nicely separated. They're not clustered randomly. They are nicely apart. So maybe there is a straight line which we can use to separate them. So yeah, this works, right? So this is a straight line. This divides these two data points into two parts. One part is red and the other part is blue. So yeah, why don't we take this then? So let us assume this is the answer we're looking for. But immediately we run into a problem. Not one, not two, not three. We have many possible lines which does the job perfectly. It divides this entire data into two parts, not necessarily equal, but it divides completely. And to add more problem to our existing problem, let us take some arbitrary line and let us say, you know what, I am lazy, I don't want to do anything, I'll just take this line and call it a day. And if you do that, you take a data point over here. As you can see a black mark over here, right? This is an unknown data point, meaning we are seeing it only now. So if you are going to classify this with respect to this line, we would bin it as a blue, right? Because this is in the region of blue. Wherever blue is there, this point is lying there. So this point becomes blue. Cool, right? So we are able to classify it. But we run into one problem. If we choose a different line, the same data point can be classified as red. So we have to solve this problem and we have to classify our data. So how do we do that? We do that using, we have many techniques to do it, but for this specific data type, we're going to use support vector machines. So what the support vector machines is, you're going to find a line as shown in this diagram in such a way that the row value over here, you can see the width, this is called the margin width, this should be maximum. So in many possible lines over here, each and every single line will have its own row width and will have its own support vectors, but we will choose the line which has the maximum row width and the maximum distance of separation between them. The center line you see, the center thick black line you see, is called the maximum margin hyperplane. And again, this is just ML lingo, nothing to worry about. So we would choose a line in such a way that the maximum distance, the distance you see in the graph as rho, should be very high amongst all possible lines. And these special points which lie on the small gray line, you can see the gray line over here, small gray line, the red points over here and the blue points over here, these special points are called support vectors. We'll go more in depth in the next session, part 2. So this is essentially what your support vector machine does. It helps you to classify data into two different parts. So similar classification algorithm is KNN, and KNN stands for K nearest neighbors. So last time we had a very beautiful data which had a very visual separation, but this is cluttered and clunky and messy, right? So for this sort of data over here, you see, we have to classify a never before seen data point as either red or blue, because all our data have only two labels, either red or blue. So given a new data point, we need to be classifying it as either red or blue by using ML. So one very good algorithm to do that is K nearest neighbors. So suppose this is our data points and you enter a new value, like a new never before seen value. So you have to classify it. So to classify that, we take the K nearest neighbors. The K is any integer. So let us assume K to be 3 for this example. So as you can see, this small question mark over here, this is never before seen data. We have not seen this in the training data. We are putting in this value and we are trying to figure out whether this will be blue or red. So by using KNN, what KNN tells us is you take the K nearest points of this data point. So we are taking K to be 3 in this example. K can be any value again. To find the optimum value of K is purely dependent on the algorithm, the computer you're going to use, and the scale of data you're going to work with. So in this example, when you take K to be 3, you can see the 3 nearest neighbors are all having one property in common, which is red. So naturally, by K nearest neighbors algorithm, we classify this unknown data point as red. We would, and a different case over here, you can see this question mark over here. This is yet another unknown data point, but in this case, it is very near the K nearest neighbors. That is the 3 nearest neighbors of this data point is 2 blue marks and 1 red mark. So among the 3 nearest neighbors, we can see blue is coming more. Blue is very common observation. So we can classify this as blue. So that's it, guys. This is what KNN is. And thank you all for joining today's session. I hope you had a wonderful time. And I would ask Shriyansh to take over the session. Thank you.
Oh, thank you, Disshad and Khushi. It was such a I also learned so much about ML today, and I hope everyone got to learn as much as I did. So, before we all leave and enjoy our weekend, I would like you to fill up our feedback form so that we can bring in much more events like these on the domains you want to get more knowledge in. And this is just the beginning. Join our Discord server to get links of all the resources and a community where you can ask your doubts and hang out with like minded people. So, once again, thank you one and all for being here. And with that, let's sign off and see you all next time. Happy weekend.